In the last few movies, you've learned how lights and cameras transfer between Revit and 3ds Max. In some cases, it is important to have that information coming from Revit. In others, lights and cameras may already be set up. In this movie, you'll explore that scenario by linking the museum model into an already existing scene. In 3ds Max, open the file named cityblock.max. If you're a regular on this channel, you might recognize the scene. It shows part of a city, complete with roads, construction lots, and buildings. There are some additional elements hidden from view at this time, such as traffic lights, stop signs, bus stops, and others. Although you can't currently see them in the viewport, they are set to show at render time. That's courtesy of an option named Render Hidden Geometry that you can enable in the Render Setup dialog. More importantly, you'll also notice that the scene already contains a daylight system set for an early afternoon render. Other adjustments, such as exposure control and a background, have already been set. Because the daylight scenario is already in place, you wouldn't want to add another daylight system coming from Revit. Also, there are a couple of camera shots already defined, and you will be creating and animating others later on. For that reason, you don't absolutely need to include cameras coming from Revit either. Therefore, you will import and link the museum you worked on previously, but you will use the link preset you created in the last movie. This way you ensure you bring in all geometry, but discard any cameras or daylight systems that are stored in the FBX file. In Revit, you can use the file named 05museumfinal.rvt. You need to export this file as an FBX file. You can also simply use the FBX file named 05museumfinal.fbx that was provided to you. In 3ds Max, ensure the 3D view is set to perspective. Use Views, Restore Active Perspective View to get back to the original shot of the city. Import and link the museum file you saved as an FBX file. As mentioned a second ago, you can also use the file name 05museumfinal.fbx. However, make sure you select the preset you created earlier. If you remember, you set this one to discard Revit daylight system and cameras, and to also retain any material changes done in 3ds Max. Attach the file to the scene. After a few seconds, the museum is imported. Dismiss the Manage Links dialog and dock the Scene Explorer back to the left side if you need to. Zoom in on the model in the top view. If you want, press F3 to see the view in shaded mode. The museum comes in part of a hierarchy, with the main node acting as a parent. This makes it easy to relocate the museum where you need it, in this case, the gray empty lot near the center. With the cursor hovering over the top view, press Alt-W to maximize that view. You'll notice that the imported geometry is at a slight angle, 6 degrees to be exact. This is how the architect set his Revit scene before rotating it. No matter. With the main parent still selected, use the Rotate tool to rotate the museum 6 degrees on the Z-axis. Zoom in a bit more, and use the Move tool to center the project on the empty lot as best you can. As part of his design, the architect planned the plaza to be sunk under the sidewalk level. Unfortunately, the lot's surface itself, which is at the same level as the sidewalks, is cutting through the plaza space. You'll need to make a hole where the gray paving stones are laid. In the top view, go ahead and select the existing ground surface and go to the Modify panel. Enter Polygon mode and then select the construction lot. You need 2 vertical cuts to subdivide this surface in order to get rid of the centerpiece. Use the Quick Slice tool to specify 2 points defining a vertical line along the left edge of the plaza. Use the F3 toggle to see which display mode works better for you. Repeat for another slice at the right edge of the plaza. The surface is now divided into 3 parts. Exit Quick Slice mode and select the center surface and then delete it. Exit Polygon mode when done. Maximize the perspective view and zoom in on a corner of the plaza. It's a little bit high because the top of the plaza is set to 2 feet above level 0, and the lot is only about 6 inches high. Select the FBX route again, and then move the museum down on the Z-axis. A value of about -1 foot 8 inches should work nicely. The plaza surface has its own material defined in Revit, but here you want to use the existing paving stone material. Open the material editor. Use the material picker to sample the plaza's surface. A new material appears. It seems to be based on some bitmaps, but you can't see that effect in the viewport just yet. Select the material and then use Show Shaded Material in Viewport. The material appears, but the scale is too small. That's not an issue since you are planning to replace it. In the material editor, ensure the option Move Children is enabled and move the material to the side to make space. Use Pick Material again, but this time sample the gray pavers. A very long material definition appears. It encompasses all materials used for the road marking, sidewalks, and lots. The one you are interested in is the one before last. Drag the out socket of that material and drop it on the surface of the plaza. It looks good, but you can tweak it further to ensure it is aligned with the existing layout. Make sure the plaza surface is selected and add a UVW map modifier. This controls the projection of the bitmap onto the surface. Make sure the UVW map modifier is set to planar mode and that it is using real-world map size. Expand the modifier and select the gizmo. Use the Rotate tool and give it a -6 degree rotation in Z. It still needs a 90-degree rotation to align itself with the existing pavers. Zoom in and fine-tune the Move Y values for a perfect match. Exit Gizmo mode when you are happy with the results. This is a good start, but we're not done yet. There are some additional materials to adjust, almost everywhere around the museum. You can certainly try to do that in Revit and update the link. However, as you get comfortable with 3ds Max's material editor, you may find it easier to do that kind of work here. This is the approach you will take for the rest of this project. In fact, once you know the geometry is finalized, you can opt to bind the FBX file to make it a permanent part of the 3ds Max scene. Caution, this is something you would only do when you are absolutely certain no more changes need to happen in Revit. If that's the case, then you can go back to the Manage Links dialog and under File, bind the link geometry. You get a warning reminding you that updates are no longer possible. If you are sure, click Proceed with Bind to make the museum independent from the FBX file. This way, you can take the Max scene and copy it to another system without needing the FBX file to tag along. In the next movie, you adjust more materials around the plaza area.